Hello, my name is Jimmy Ale James Bailey, matrix number of CD190011. So today I'll be talking about introduction. So introduction about our report is more to forging. Forging is an integral part of the manufacturing process. Most efficient metalworking techniques because it allows a metal product to be easily shaped into a useful shape using dies and tools. Generates a product with excellent mechanical qualities and minimal material waste, better manufacturing technique than other methods, defined as the plastic deformation of a bulk metal into a predefined shape by compressive pressure applied by a hammer or press. A traditional approach that is divided into two types: open die and closed die forging. Diverse range of goods in terms of shapes and size, materials, and customer base. On lower the cost of the forging process, the technique should be developed so that the best parameter set may be utilized to manufacture high quality products as opposed to other production methods. That's all from me. Thank you.
Theoretical and experimental modeling. Forging is a manufacturing process involving the shaping of metal using localized compressive force. The blows are delivered with a hammer, often a power hammer or a die. Forging is often classified according to the temperature at which it is performed. Cold, cold forging, a type of cold working, warm forging, or hot forging, a type of hot working. For the latter two, the metal is heated, usually in a forge. Forged part can range in weight from less than a kilogram to hundreds of metric tons. Forging has been done by smiths for millennia. The traditional products were kitchenware, hairware, hand tool, edge weapon, symbol, and jewelry. Since the Industrial Revolution, forged part, part are widely used in a mechanism and machine wherever a component requires high strength. Such forging usually required further processing, such as machining, achieve a finished part. Fogging is a compression of a part between the two flat dies, is similar to compression test when one part has cylindrical cross section and is compressed along its axis. Deformation operation reduce height and increase the diameter of fork. Common names include offsetting or
Hi,
offset
hello,
fogging.
I am Jasbir Singh, son of Sarjeet Singh. My metric number is CD190009. Today, I would like to present about design, numerical and experimental analysis of our group project of manufacturing technology entitled Bulk Deformation Process in Metal Forming. As our group project focus on fogging, let I explain about the numerical stimulation of asymmetric fogging. The following are the primary input data for numerical simulation, which are the mechanical and physical properties of the fogging material, geometry of the tool, condition of the friction, and the parameters of technology. While the temperature of the fogging motion and the ram velocity are two technology parameters. In report, we can see the layout of fogging tools before and after, and the shape of fogging part after the final fogging. And we also came out with the numerical mesh and symmetric plans definition, which is carried out by using Lisa software, and workpiece station and the temperature field after transport to compression tool. And we also shown the example of temperature distribution after standby time, and we also provide the shape changes during compression process and fiber flow in fogging. That's all
Hello,
from
my name
me.
is Indrigan
Thank you.
Colin from Group 8, and my matrix number is CD190215, and I will be presenting about the experimental setup. The experiment was carried out at room temperature on a 1.6 mm computer controlled hydraulic press at constant path velocity. The two core forming processes were chosen: one rectangular block compression and three forging of a spur gear part. Material used is a technical pure EICM and aluminum. The material stress strain curve was produced by compression tests performed on cylindrical specimen with a Teflon briquetting foil around 0.1 mm thickness to ensure homogeneous deformation. There was lubrication in cold forming trials. The ring approach was used to estimate the tribological condition of a die workpiece contact interface. Friction was given in terms of constant friction factor, M, and the finite element approach was used to create calibration curves relating changes in minimum internal diameter as a function of a height reduction. The effective strain distribution was estimated using an experimental technique based on micro-hardness tests done on a metal component itself. Because micro-hardness measurement SV 0.5 were performed in accordance with ISO 6507/2 at predefined grid points with a 1 mm step length between each indentation point. And that's all for the experimental setup from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haris Hamizan bin Hamzah. My metric number is AD190243. So I would like to continue our presentation with result and conclusion. Compression of rectangular blocks. I-Form 3 was used to accomplish three-dimensional numerical simulation work. Hexahedral, which is 8 node, and linear triangular element were used to discretize model and matrices respectively. Figure 5 depicts the basic model as well as the geometry progression of hexahedral mesh. The figure 5 shown computed evolution of the compression of rectangular blocks at different stages of deformation for a mesh model containing 1000 hexahedral element, which is initial shape 23%, 42%, and 75% reduction in height. Computed an experimental result for rectangular block compression at 42% height reduction. The left the experimental part in detail, and right is the first quadrant contain computed an experimental profile, which is open square. The second quadrant contain the grid position for Vickers micro hardness measurements. The third quadrant contain the FEM distribution of the effective strain, and the fourth quadrant contain the effective strain distribution obtained the micro hardness measurement. Next, fogging of spurs gear part. The numerical simulation was carried out in I-Form 3. Hexahedral, which is 8 node, and linear triangular component were used to discretize billets and dies. Each billet's original diameter and height were 17.75 mm and 22.96 mm respectively. Only half of a tooth was discretized due to symmetry. Multiple mesh models were used through the project, and several remeshing processes were required to assure accurate modeling of the forging process. So this is the graph. Figure 7 despite the peak of the development of the load with respect to the punch displacement. Three distinct stages can be identified: an initial stage in which the forging load evolves smoothly and similarly to what is typically obtained for heading operation, with flat punches, and a second stage in which the forging load increases at a faster rate due to the extrusion mechanism that occurs when the teeth are being filled, and a final stage in which the forging load increases sharply in association with the contact between the formed teeth and the die insert. Last but not least of our presentation, the conclusion. This study conduct a thorough examination of the major theoretical and numerical aspects associated with three-dimensional finite element modeling of bug forming process. There were several types of solvers and resequencing algorithm examined. The finding demonstrate that using a skyline solver is in conjunction with Sloan's reordering technique yield the best result for a penalty-based formulation. Through the investigation, numerical and experimental findings compare well, establishing iForm 3 as a credible software tool for modeling three-dimensional bug forming process. That's all from us. Thank you.